Hi everybody, in this video we're going to be talking about how to teach the subtraction algorithm for whole numbers. So just like when we are adding whole numbers, I highly recommend that you use base 10 blocks to help your students visually build the concept of how to subtract whole numbers. So if we have the number 1,752 and we want to subtract 321, then I'm going to have 1,000 and 700. So here's 1, 2, 3, 4, 5, 6, 7. And I'll move these over so we can see the other place values just fine. So we have 7 hundreds. And then we have 5 tens. So here's 1 10, then 2, 3, 4, 5, and 2 ones. And with this original problem that I'm doing, this is a very easy problem because it doesn't require any borrowing. And you definitely want to start with that when you're teaching your students subtraction, and then give them harder problems where you're borrowing. So if we start off with this easy problem, we say, okay, we have this number and we want to take away 321. Well, your students might take away the blocks in any order. Like they might say, okay, I'm going to take away 300s. So these are my 300s that I took away. And then I'm going to take away 2 ones, or excuse me, 2 tens. And then they want to take away 1 1. And when they take those, when they take that away, the amount that's left over is 1,000, 400s, 3 tens, and 1 1. And so the answer is 1,431. And it's fine if your students subtract in this way to start with. However, when you move on to a more challenging problem like this one, where you have 1,241 minus 568, they'll realize that there's more efficient ways to do it. So to visualize this one, I'll have 1,000, 200s, and 4 tens. So 1, 2, 3, 4, and 1 1. So we start off with that number and you say, okay, like I want you to take away 500, 6 tens, and 8 ones. And the students are like, well, you can't do that because there aren't that many. And they might start off by taking this block and exchanging them for 10 hundreds. Or they might start by taking the 10 and exchanging that for 10 ones, or taking one of the hundreds and exchanging that for 10 tens. But ultimately, all of those things are going to happen because in order to subtract 8 ones, you have to have 8 ones. And to subtract 6 tens, you have to have 6 tens, at least that much. And so you can use this block model to show them that they need to borrow from bigger place values if they don't have enough numbers in the place value to subtract what they want to. So for example, you can say, okay, well, I used to have 4 tens, but when I converted them into ones, I then had 3 tens, but I had 11 ones. And so you can show them that shorthand for you got rid of one of your tens, so now you only have 3 tens, but you have 11 ones now. And same thing with the hundreds. I used to have 2 hundreds, but I took one of the hundreds and converted it into tens, which gave me 13 tens and only 100 left. Same thing with the thousands. I borrowed one of the thousands, which means that I have 0 thousands, but I have 11 hundreds. And so that's the way that you write out this process that I showed on the board visually, of taking my thousands block and breaking it up into hundreds, taking my tens blocks and breaking them up into ones, and so on. And then once you have it like this, then you can go through the same process of subtraction where you say, okay, I'm going to take away 8 ones. So here's 1, 2, 3, 4, 5, 6, 7, 8, and that leaves me with 3 ones, which they can compute mathematically in their head as well, because 11 minus 8 does equal 3. Then you can say, okay, then if I have 13 tens and I take away 6 of them, so here's 1, 2, 3, sorry, this is taking a minute, 4, 5, and 6, and the number of tens that I have left is 7. And you can also point out that 13 minus 6 equals 7 as they're memorizing their subtraction facts. And then you can show with the hundreds and say, okay, well, if I take away 5 of my hundreds, so here's 1, 2, 3, 4, 5 of my hundreds, the amount of hundreds that I have left are 1, 2, 3, 4, 5, 6 hundreds. And again, 11 minus 5 equals 6. And that's the reason why the subtraction algorithm works the way that it does. And you can also use a chip abacus as a more abstract way of visualizing this same process. So after you've shown your students how to do it with base 10 blocks, you can have them practice it on their own with a chip abacus. And they could go through and solve this problem by saying, okay, well, if I have 1,000, then I should have 1 chip in my thousands column. If I have 2 hundreds, I should have 2 chips in my hundreds column. 4 tens, 4 little chips in my tens column, and 1 is 1 chip in my ones column. And then you can say, okay, well, if I want to take away 568, well, I can't take away 8 ones from 1 because there isn't 8 in that column. But I could take my 10 chip and exchange it for 10 ones. And if you're doing this with poker chips, you know, it would be like them trading it. Or if you're doing it and drawing it on paper like I am, you'd basically like cross that one off and move it over and convert it into 10 ones. And you can show your students that that's equivalent to crossing out the 4, and now you have 3 tens and you have 11 ones. Then you can do 11 minus 8 equals 3. And so what that would look like is you basically take away these 8 from the ones column, and you have 3 that are left. And then you move on to your next place value for your tens column, and you say, okay, well, I can't take away 6 tens because I only have 3 tens. So I'm going to take one of my hundreds chips and convert that into 10 chips. So now I have 10 chips, and I can take away 6 of them. So I'll cross out 6 of those. And what I would write this as is I would say, okay, well, I had 2 hundreds, but then I took one of them and converted them into tens, which gives me 13 tens. 13 tens minus 6 tens leaves me with 7 tens. Then you go through the same process for the hundreds and the thousands, and you say, well, I can't take away 5 hundreds because I only have 1. But if I cross off this thousands chip and exchange it for 10 hundred chips, then I have 1100 chips. And the way I would write that is I would cross off my 1,000. So now I have 0 thousands, but I have 11 hundredths chips. And I'd say, okay, well, 11 minus 5, if I take 5 of these and I get rid of them, the amount that I have left is 6. And so that's how I could model that the answer to this problem is 673. And again, notice it's the same process as the base 10 blocks. It's just more abstract because the chips are all the same size versus the blocks show the size of the numbers more clearly. So that's how you would do the subtraction algorithm with a chip abacus and with the base 10 blocks. If you have any questions, let me know.